Okay, 6.3, solving systems using elimination. Basically, our goal is to eliminate one of our variables so we can solve for the other. Okay, so let's take a look at number 1. Okay, so for number 1, what we always need to look for and see if there's any of our variables, either both are x's or y's, where both of the numbers are the same, but the signs are different. If that's the case, that's the variable we want to eliminate, and we can do so by adding. In this case, both y's have the same number, they have 11, and one of them is a negative 11. So what we would do is we would add these together. 4x plus 3x is 7x. 11 plus negative 11 is 0, and then 12 plus 9 is 21, so the y's go away. So then we divide both sides by 7, and then x equals 3. Now to find y, we substitute x in for either the first or second equation. I'll put it in the first. We have 4 times 3, take the x out, replace it with 3, plus 11y equals 12. 4 times 3 is 12. Then we subtract 12 from both sides. We'll get 11y equals 0. Divide both sides by 11, and y equals 0. So our solution will be 3, 0. There's number 1. Okay, number 2. Again, we are using elimination, which means we are eliminating one of our variables. And we always want to see if there is any of the variables that have both numbers the same, just one being positive, the other being negative. In this case, we do. We have the y's, both being 12, but one of them being a negative 12. So we can simply add them together. X plus x is 2x, and 14 plus negative 10 is positive 4. So then we divide both sides by 2, and we get x equals 2. So now we take the 2 and substitute it in for x. So you have 2 plus 12y equals 14. Subtract both sides by 2, we get 12y equals 12. Now we divide both sides by 12, and we get y equals 1. So now we put that together as an ordered pair, and we have 2, 1. Okay, so we have 2, 1. Let's put that in. Okay, so looking at this one, both the x's are different, the y's are the same, including their signs, which means we're going to have to multiply either the top equation or the bottom by negative 1 in order to make them opposite signs and to make the 9 positive. It doesn't matter which equation you choose, you'll still end up with the same answer. So let's start, and I'm going to use the first one. So then I'm going to multiply the top equation, every term in it by negative 1. So I'll get negative 15x plus 9y equals negative 3. And then now I can add that to the bottom equation, which is x minus 9y equals negative 25. Negative 15x plus x is negative 14x, and negative 3 plus negative 25 is negative 28. Divide both sides by negative 14 to solve for x, and x is going to equal 2. So now I'm going to take that 2, it's substituted in for the first equation, and I'm going to solve for y. So 15 times 2 is 30. Now I'm going to subtract both sides by 30, and I'll get negative 9y equals negative 27. I'll divide both sides by negative 9, and y would equal 3. So now putting that as an ordered pair, I'll get 2, 3. Okay, so then I'll put in 2, 3 as my answer. Number 5. Your school's talent show will feature 8 solo acts and 3 ensemble acts. The show will last 70 minutes. The 4 solo performers judged best will give a repeat performance at a second 50-minute show, which will also feature the 3 ensemble acts. Each solo act lasts X amount of minutes, and each ensemble act lasts Y minutes. Use this information to answer parts A and B. So we know X is solo X and ensemble is Y. So we first have the first part of the feature will be 8 solo acts and 3 ensemble acts, so 8x plus 3y. The show will last 70 minutes, so 8x plus 3y equals 70. That automatically tells you it has to be B. That's the only option where we have 8x plus 3y equals 70. And we can see that, too, for the second part of that, 4 solo x, so 4x, and then the 3 sumo x, which is 3y, will equal 50. So that would be B. But now we got to solve that system. Okay, so now that we have that, we got to make one of the y's negative since both the numbers are the same. Okay, so I'll take the top equation and multiply everything by -1. So doing that, I'll get negative 8x minus 3y equals -70. Add that to the second equation, which is 4x plus 3y equals 50. I'll get negative 4x plus negative 8 plus 4x is -4. Negative 3y and 3y is 0. Negative 70 plus 50 is -20. Divide both sides by -4, and x equals 5. So now I need to find y. So substitute 5 in for x for the first equation. 8 times 5 is 40. So 40 plus 3y equals 70. Subtract 40 on both sides. I'll have 3y equals 30. Divide both sides by 3, and y will equal 10. So my ordered pair then would be 5, 10. That's what it's asking for B. So parenthesis 5, 10. So it now says, how long is each solo act? Solo is x, and we said x was 5, so 5 minutes. And ensemble acts is the y, and that's 10 minutes. And then that's number 5. Okay, number 6. Looking at these two equations, not only are the numbers in both variables different in both equations, but the signs are also the same, which means we're going to need to multiply top and bottom, not just by a number to make the numbers the same, but we got to make sure that we multiply the correct sign so that they're opposite signs. So here's our system. Now, it looks like it might be easier just to multiply the bottom to make the x's the same, because all we have to do is multiply it by one number. Now, since we have a 2x here, we're going to want this to be a negative 2x so that when we add them, we get a 0. So we'll multiply the entire bottom by -2. Okay, so -2 times the entire second equation will end up getting negative 2x minus 10y equals -14. Okay, so -2 times 5y is -10, and 7 times -2 is -14. So now we could add the top equation to the new, improved, and changed bottom equation. So now -2x plus 2x gives me 0. 3y plus -10y is -7y, and 7 plus -14 is -7. Divide both sides by -7, we'll get y is 1. But now we need to substitute inside one of our equations with 1 to get what x is. So I'm going to use the first equation. I'm going to replace y with 1. So then 3 times 1 is 3. But then I need to subtract both sides by 3. I'll get 2x equals 4. Divide both sides by 2, and x equals 2. So now writing that as an ordered pair, I'll have 2, 1. And that's number 6. Okay, number 7. Looking at these equations, we see for the x's, both numbers are different with different signs, and both numbers of the y's are different with different signs. So that means if we're going to eliminate one of our variables, we're going to have to multiply both the top equation and the bottom equation to make that happen. So looking at both of those equations, I can either choose to multiply numbers to eliminate the x's or the y's. Doesn't matter, you'll end up getting the correct answer at the end. I'm going to go ahead and try to eliminate my x's. So, looking at both the numbers, I have 5 and 3. I can make both of these numbers 15, but in order to eliminate them, one of them has to be -15. So I can either make the top number negative or the bottom number negative. Again, your choice. I'm going to go ahead and multiply the top by +3 because 3 times 5 is 15, and then multiply the bottom by -5 because -5 times 3 is -15. So I have the positive and negative 15. But when you do that, you got to multiply everything by that number in the equation. So looking at the first equation, I'll have 3 times negative 2 and 3 times 12. And that gives me 15x minus 6y equals 36. So now for the bottom equation, I'm multiplying everything by negative 5. So then this term would have a negative 15. So negative 5 times 5y is negative 25. And then negative 5 times 1 is negative 5. So then this will be the equation once I multiplied everything by negative 5. Now we see if we add these two, they become 0, and I can eliminate my x. So let's do that. So we're going to add them. So negative 15 and 15 is 0. Negative 6y and negative 25y is negative 31y. And 36 plus negative 5 is 31. Divide both sides by negative 31, and y is going to equal negative 1. So now to find x, I'm going to substitute it in for my original equation for y. So I'm going to take the y out, so I have 5x minus 2 times negative 1 equals 12. Negative 2 times negative 1 is positive 2. Subtract both sides by 2, and we'll have 5x equals 10. Divide both sides by 5, and x equals 2. As an ordered pair, that would be 2, negative 1. So put that in mathematical cells, so we have 2, negative 1, and that's number 7.